Module 6, Objective 6, identify the main functions of the diencephalon, which include the thalamus and hypothalamus, including a discussion on centers controlling emotions, autonomic functions, and its relationship to the endocrine system. The thalamus filters and relays sensory information from the spinal cord and cranial nerves to the cerebral cortex. It's sort of analogous to Grand Central Station in New York City. Grand Central Station is a subway station, and all subway lines go through it. In the similar fashion, all of the information, the sensory information coming in from various parts of the body, they all go through the thalamus, or at least they tend to, before being projected up onto the cerebral cortex. So as the sensory informations travel in, they all go through the thalamus, and then it's the role of the thalamus to sort of decide what gets projected onto the cerebral cortex. And what that means is that if a sensory information is projected onto the cortex, onto the sensory cortex, we become conscious of it. We become aware of it consciously. So that is the role of the thalamus. And you can see that it's divided into a number of groups. So we have the medial group, the anterior group, the ventral group, the lateral, and the posterior. In terms of the functions of these various groups, it gets sort of complex. So all I'm going to ask is that you know one or two bullet points in terms of the major roles of these various groups. So the anterior group is part of our limbic system. And limbic is our system that handles our emotional states. So we'll just leave it at that. The medial group provides awareness of those emotional states. Ventral group is going to just relay sensory information. The posterior group is also relaying sensory information, mainly from the eyes and the ears. And then the lateral group is going to exert effects on emotional states. It's going to help integrate sensory information coming from various parts of the body. So again, there's a lot of complexity here. The main thing I'd like you to know, aside from these few bullet points under each of these groups, is that the thalamus sort of serves as that grand central, in that all the sensory information is going to go through the thalamus. So the thalamus is responsible for deciding what is projected onto the cortex and therefore our awareness. The hypothalamus is located directly underneath and just anterior to the thalamus. So here's your thalamus in a sagittal section of this brain. The hypothalamus is located in this region. So just anterior and just underneath or posterior to the thalamus. And there's a couple structures within the hypothalamus that are worth noting, and we can see these structures down here in this lower image. The first structure that I'll identify are the mammillary bodies. And if you look at the brain from an inferior perspective, the mammillary bodies look like two small mounds. And of course, early anatomists, being primarily men, they thought they looked like breasts, so they called them mammillary bodies. And the role of the mammillary bodies is two parts. One, it plays a role in memory. So damage to the mammillary bodies or any type of trauma to the mammillary bodies would definitely affect one's memory. It's not the only part of the brain associated with memory, but it does play a role. Also, it controls reflexive eating movements. Just anterior to the mammillary bodies, we have a stalk. And I want to use a different color so as not to confuse. The stalk, and I don't know how well I'm going to be able to portray this, is right there. So we have a stalk, and the stalk holds a very large important gland called the pituitary gland. And again, we can see the pituitary right here, or here. Maybe this is a better shot of it, and for that I will use black. So here's your pituitary gland, And here is the stalk that holds it, S-T-A-L-K, the stalk. And we call that stalk the infundibulum. And it's going to help connect the hypothalamus to the pituitary gland. And we'll see in AMP2 when we cover endocrinology, the relationship between the hypothalamus and the pituitary gland. And then just anterior to that, we have the optic chiasm, and that's noted right here in cross-section. Again, if you were looking underneath from an inferior view of the brain, the optic chiasm is right here, and it's this area where these nerves sort of cross, and these nerves are the optic nerves, and they're going to go to the eyeballs. So the optic nerve leaves the eyeball, and they travel posteriorly. Here your eyeballs would be. They're going to travel posteriorly, and they're going to cross right there in front of the infundibulum, and that is called the optic chiasm. And I will just spell that out. Optic chiasm. So they cross there, and then they shoot back to the occipital lobe of the cerebrum for processing. So those three structures, the mammillary bodies, the infundibulum, and the optic chiasm, sort of delineate this hypothalamic region. The tuber cinerarium is between the infundibulum and the mammillary bodies, just a little region between. And this region contains neurons that produce hormones that affect the pituitary gland. Here we see a sagittal section of a dissected brain. Just to orient ourselves, here we have the cerebellum, posteriorly oriented back within, again, the occipital bone. We have the thalamus is right here. Here's your hypothalamus, and you can see the mammillary bodies, the tuber cinerarium, the infundibulum, and then the optic chiasm here as well in cross-section. Here is the pons, and of course the medulla oblongata would be directly under that in this region. And then of course the spinal cord would continue down. So these are the major regions that we've covered thus far. In terms of functions of the hypothalamus, overall they provide subconscious control of skeletal muscles. They coordinate activities between the nervous and endocrine systems. They help produce emotions and behavioral drives such as hunger and thirst. The hypothalamus helps regulate body temperature. And lastly, it helps control our circadian rhythms, our day-night cycles. When the sun goes down, we should get tired. And when the sun comes up, we wake up. And those are our circadian rhythms.